In this video, we're going to look at the end behavior of graphs of polynomials, and we're going to start with a few things here, just looking at what is in the equations, and then we will use our graphing calculators today to look at the graphs as well. So if you want to get the Desmos graphing calculator ready, you can follow along with this video a little bit easier. If at any point that we go too quickly, just pause the video and or rewind. So first thing we're going to look at today with our polynomial functions. So these equations that have multiple variables showing in many of the cases, multiple terms, multiple pieces. And what we're going to first talk about is the degree of these polynomials, which is simply what is the biggest exponent that you see. And exponents, remember, are the little numbers that are written above a variable. So when we look at number 1 and we want to find the degree, we see an 8, a minus 2x, and a plus x to the second. And the exponents that we see are the exponent of 2 and the understood exponent right here with the 2x. This is x to the first. So there are two exponents we can talk about. We have 2x to the first and we have x to the second. And we are not looking at the biggest number in the equation, but we are looking for the biggest exponent. And that biggest exponent is right here. It's that number 2. So our degree of this equation is 2. When we keep looking, we go to the next part here, next equation, and we see it says x to the third minus 5x to the fourth plus 2x to the second. We want to know the degree. So the degree of this equation, okay, we're finding degree. We're going to look for our exponent. We're going to find the biggest exponent that's here, and that is the exponent 4. So the degree of this one we'll say is 4. For equation 3, f of x equals 10 minus x, the only place we see the variable x is right here. And there's no exponent that we see. We recognize that's the exponent of 1. That's understood. So sometimes the degree of our polynomial is just the number 1. And lastly here, we have 7x to the third, also said as 7x cubed, plus 2x minus 9. And with this one, again, we have an exponent of 1 right here in the middle. And we see a lot of numbers in this equation. But again, we're just looking at that exponent. We want an exponent of 3. So the biggest exponent we see is 3, and that is our degree. So exponents are not always, or degree is not the biggest number in the equation. And it's not always the exponent that's at the beginning. The exponent could be anywhere in the equation. We just want to know the largest one. So we're going to use that a little bit to talk about our graphs. And we're not making super detailed graphs here. We just want to talk about what are some of the things they should do. And part of that discussion is what degree does the equation have? So our first equation, we see y equals x. And we want to make a graph of this, but we can also start talking about the exponent we see with our variable x. And we could think of this as being y equals x to the first. And if 1 is our biggest exponent, that is our degree. So what we want to talk about after that is, if our degree is 1 an odd or an even number? And 1 is an odd number because we cannot divide it by 2 evenly. So 1 is an odd number, and because of that, we're going to see a couple things. Before we jump into that, let's get this equation. I'm going to draw the x and y axis in. So I'll just put the y-axis here somewhat in the center, same with the x-axis. Okay, so we've got both the x and the y-axis here, and we want to draw the equation y equals x. And there's no table for this one here. We can type it in. If we type in y equals x into our calculator, it makes a line, but the only dot it shows is at 0, 0. But there are more places on this line. If you click and drag on this line, you'll see there's another location at 1, 1, at 2, 2. And that's because this equation has y equals x. The x and y values are going to match. Now, giving you a sneak peek into a couple of examples from now, if we use the edit list button that looks like a settings tool, if you click on this after typing an equation, you can click on the create table button here, and it'll also tell you more points you can show on your graph. So here's those points we were just talking about: -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. I'm just going to go onto the graph, show these 5 dots really quickly, and draw a line through it. So drawing this equation, we've got -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. And we can draw a quick line through there. And you don't need to spend too long making your graphs today. We really want to talk about what's going on. So when we look at your graphs, we want to talk about what's happening on the left side, and the left would be over here, versus what's happening on the right side of your equation. So the right way over here on this end. And when we look at the left side of this graph, this arrow is pointing down. And since this graph is pointing down, then we want to describe that this graph is going down forever. We describe forever with a value of infinity. So to say that the graph is going down forever, what we're going to say for the left side of this graph is we're going to say the left side is going down forever. That's going down to negative infinity. So we'll put that negative infinity right there to express that this side of our graph is pointing down, and it will continue to do so. The right side of the graph, we can do the exact same thing. The right side of the graph is pointing upward. So for the right side here, we're going to say that it is pointing up, and it continues to go up. It never stops going up. So we're going to use a positive infinity over here. You don't have to put that plus sign before it, but I just wanted to make sure we're all aware this is a positive infinity as we go up. Pretty simple. So over here is the main part that we're practicing. We're just going to get a sneak peek at some of these graphs and make a few. So let's go to the next one. It's a very similar scenario. It's just we're starting with a negative in front of x this time. But if we want to talk about the degree of it, we have x to the first. Again, so for this one, with x to the first, our degree is 1, and 1, just like before, is an odd number. Let's draw that graph again. So I'm going to get my x and y axis ready one more time here. And again, pause the video if I'm going too quickly. You got lots of time that you can do that with. Okay, we have the x and y axis. I'm going to update my equation. Instead of a negative x, or positive x, we may make this a negative. Now notice my table didn't change. The dots are all in the wrong places when I do that. That's because every time you make a new equation, you need to make a new table. So get rid of this table, make a new one here. So again, click the edit list button, the settings icon, click the XY table button, and you get a new table here with 5 new dots. These are at -2, +2, -1, +1, 0, 0, 1, -1, 2, -2. Now you can go right back to your graph and show these 5 points. So we have -2, +2, -1, +1, 0, 0, 1, -1, and 2, -2. All right, draw a quick graph through here. And it's just a line. Okay, now let's talk about what's happening on the left and the right side again. So on the left side of this graph, on the left side, this graph is now pointing up. Unlike before on the previous graph, the left side's pointing down. Now with this negative, the left side's pointing up. So to show that it's going up forever, we're going to put a positive infinity for the left side of this graph. So the left side of the graph is pointing up. The right side of this graph we see is doing the opposite. On the right side, this graph is going down. So for the right side of this graph, we'll say it's going down forever. That's the negative infinity. So we said the right side is going down. The left side was pointing up. So if you draw the arrows on the end of your graph, you're just describing which way it goes. Okay, so that was with some lines. Let's talk about some other graphs we haven't seen before where we change that exponent. Instead of an exponent of 1, we're going to bump it up to a 3 in this scenario. Okay, and it should tie into what we just said before. So what we're going to do, again, is just walk through the exact same steps. The exponent has changed. The exponent is now 3, so that is our degree. Our degree is 3 this time. You cannot divide 3 by the number 2 evenly, so 3 is also an odd number. All right, and so now as we look at this graph, we're going to type in our new equation, y equals x to the third. So let's get rid of our old table. Let's type in our new equation, y equals x. To type an exponent of 3, you can either use the 6 button on your keyboard, or you can go to the Desmos keyboard and choose the button that has a to the b. As soon as you click that, it's ready for you to type a number up high. So I can put a 3 there. And this graph looks a little different. It's not a straight line anymore. It takes a turn in the middle and has a different shape that we haven't quite seen before. But if I want to graph it, just like we're asked to here, making a table, I'll do the exact same thing. Push the Edit List button, choose my table, and there I have 5 new points. If I want to see them all, I can zoom out here just a little bit. And I should get more of a view. Okay. But those are the 5 points we need. So -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. And we can write those down here. So -8, -1, 0, 1, and 8. And it looks like we need our x and y axis again. So I'll draw these in. There's the x, there's the y. Okay. Now you're going to have to do your best to count these boxes with me, but don't stress about it too much, okay? But we need to go to -2, -8. And according to my calculator, that's to the left 2 and down 8. So I'm going to do my best. I'm going to go left 2, down 1, 2, 3, 4, 5, 6, 7, 8. This should be 8 lines below the x-axis. That one takes a little bit of effort. But then after that, pretty quick, -1, -1, 0, 0, 1, 1, and 1, 8, 1, or 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. There we go. And draw a picture that looks like this one. So draw a picture that goes up, kind of gets flat in the middle, and then goes up again. So from here, we got a graph that's going up, and here it goes. So again, we're not looking for a masterpiece of a graph. We want to talk about what is the graph doing. So if we now talk about what your graph is doing on the left side and the right side, well, let's look at your left arrow. This left arrow way over here is pointing down again. So the left arrow is pointing down. We expressed that earlier by saying going down forever on the left side, that would be a negative infinity to say it's going down. On the right side of the graph, the opposite is happening. On the right side of the graph, if we draw that arrow in, that arrow is pointing up. So here's the right arrow of your graph. That arrow is pointing up. So just like before, if it's pointing up, that means it's going up into positive numbers forever. That's a positive infinity. Again, keep pausing that video to stay caught up if we ever go too fast. After that, look, all we're going to do this equation is change it to where there's a negative in front, and that should change the graph just a little bit. So I'm going to go back to my calculator. I'm going to change this to a negative. And again, the graph changed, but the dots didn't. So don't forget, you need to delete this table, make a new one. So click that Edit List button, create a table. There it is. So we got new numbers here. It goes 8, 1, 0, -1, -8. So I'll go through those. 8, 1, 0, -1, -8. Okay. So we're ready to make this graph. I'm going to go ahead and make that first this time. So making our graph in this scenario here, I'm going to put the x and y axis on again. So somewhere kind of in the center, there's the y, here's the x. Let's show these new numbers. So this time it's -2, +8. So we're going to go over to -2 and now up 1, 2, 3, 4, 5, 6, 7, 8. That one took a little bit of effort, but not much. Keep going. -1, +1, 0, 0, 1, -1, 2, -8, 1, 2, 3, 4, 5, 6, 7, 8. Got it. And we are going to draw this graph too. And again, just follow the flow of these dots. Make a graph that looks similar to your graphing calculator. Okay, so we've got those. So let's start talking again. The exponent this time is still your exponent. So it's still an exponent of 3. And 3 is still an odd number. And we're going to talk about what happens with odd numbers soon. Okay, so we've got an odd number there. The left side of this graph, you can look at it pretty quickly. And hopefully you're catching on to this. With the left side of the graph, that is pointing up. So left side of this graph is pointing up to positive infinity. So left arrow is pointing up. Okay, the arrow on the right is again doing the opposite. So the arrow on the right is doing the opposite. That is pointing down to negative infinity. It's pointing down. Okay, so the right side is pointing down, the left side's pointing up. Okay. So that's the main task that we have is we want to be able to look at these graphs and say those things. At the end of this lesson, we're going to talk about how can we maybe know what's going to happen with these arrows before we ever make that graph. All right, so we've seen a lot of odd exponents. Let's talk about the even exponents. So on this one, we have y equals x to the second. So let's walk through. The exponent this time is 2. There's our degree. But 2 is an even number. We can divide 2 by a 2. So we have an even degree. So something different might happen this time. I'm going to go back to decimal, so I'm going to type in my equation. So again, delete your tables, update your equations. We have y equals x to the second. Okay, now with x to the second, we can make our new table. So edit list, table icon, new points here. We have negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. And all I'm going to do right now is I'm going to go on to my page and I'm going to show these 5 dots, okay? So negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. The thought behind this is a very basic graph that doesn't take a lot of work. So we didn't show a table on the paper, but we can go from our calculator to make it. All right, so let's go ahead and show those. Negative 2, 4, go up 4 lines here from the x-axis. Negative 1, 1, 0, 0, 1, 1, 2, 4. Okay. And again, with these quadratics, with x to the second, it's a U shape. So not a V. Don't make a sharp V at the bottom. Make it rounded. But again, if you can get that far, what we're really trying to get to is what's happening on each side. What is happening on the left versus the right? And we can look. The left side's pointing up. But if you look over to the other side, the right side is also pointing up. That's different than what we saw on the front page. Both sides are pointing up. So for this one, if the left side's pointing up, we're going to put a positive infinity for up. And if the right side's doing the same thing, we'll put the exact same value. So the right side is also going to positive infinity because it's pointing up. So something that was different than what we saw on the front. Let's do another one. Let's do the negative x squared. So we go back in, we change it to a negative x squared. And again, remember, the graph will change, but the dots won't because you need to delete the table and make a new one. So we have y equals negative x squared, change that, make a new table. And it looks like it's all the same numbers except they're negatives. So we're going to go negative 2, negative 4 this time. So we're going to show these 5 dots now on this graph. So just like before, I'm going to show the x and y axis again. So here's my y axis. The x axis is, I'm going to draw it a little higher so I have room to draw my dots, right? All these dots are underneath the x axis. I'm going to go ahead and show all those. So pause the video as needed, just like we said. Here we go. We have negative 2, negative 4 this time. Negative 1, negative 1, 0, 0, 1, 1, 1, negative 1, sorry, 2, negative 4. And all that happened this time is instead of a U, we have an upside down U. So here's our graph. Now, as we talk about it, there's some things that are the same. For one, the degree is still 2, just like it was on the last one. And the shape is even, or the degree is even. So we're getting a similar outcome to what we saw in the last one. The only difference is with this negative, we're seeing a graph that is pointing down on both the left side and on the right side. So the left and the right are both pointing down this time instead of up, but they're both doing the same thing. So we're going to put the same value over here. Since the left side is pointing down, we're going to put that negative infinity. And the right side's doing the same. So we're also going to show that negative infinity for the right. Okay. So that's really our goal. So we can make some graphs if we need to, but let's look at a couple that have the graphs already there. These look a little bit different. If you see them, it's kind of hard to see it. I get that, but if you look, I'll trace this out. It's a W shape, if you can see it. And it's a W shape because of the exponent we have. We have a new exponent this time. This one is x to the 4th. There's also an x to the 2nd, but remember, the degree is your biggest exponent. So the degree is 4 this time. Now, 4 is an even number. If you look at the two ends of this graph, though, the left side is still just pointing up. So we can still say that. We can say the left side is pointing up. So I'm going to go ahead and write the word up here. It looks like we changed our notation. And I'm going to show the same thing for the right side. The right side is also pointing up. So what happens if we go to number 12 and it's the same equation except we change the signs? It's still x to the fourth and 4x to the second, but what happens when we change the signs? Well, the graph just flips upside down. We're just going to take that w and flip it over. And that's what happens every time we put a negative in front of a graph like this. The graph is going to flip over. So instead of our two arrows pointing up, the two arrows in this case are both pointing down on the left side and the right side. But there are some things that are the same. We do still see that the degree is 4, and 4 is still an even number, and that the left side and the right side are both doing the same thing when that happens. The left side's pointing down, the right side's pointing down. Okay, so that's our overall goal. So let's see if we can wrap this up. Notice all of these graphs on this side of the page, the left and the right were doing the same thing. They're either both pointing up or both pointing down. Well, that is what happens when we have an even degree, when our degree is even. So I'm going to hop over here. For the even degree, we're going to say that the ends are doing the exact same thing. They are the same. If the leading coefficient, that's the first number, if it's positive, if your equation starts with a positive number before x squared, like this would be a positive 1 right there. If your degree starts with a positive 1, they're both going to do this. They're both going to point up. So the left and the right are going to point up. So we're going to see an up and an up. Versus if it starts negative, it does the opposite. The left side points down and the right side points down. Whether it's a W or a U shape, we don't know, but I do know that that's going to happen. With the odd degree, it's different. With the odd degree, they are not the same. That means one end has to point up and the other points down. So if you go back here, and again, pause the video as needed, but if we go back to this side, one side of the equation points down while the other points up. We see that over and over again. Left side down, right side up. Left side up, right side down. It keeps happening. So for this one, we see that if the equation starts with a positive, like y equals positive x, y equals positive x to the third, the left side's pointing down and the right side's pointing up. So that's what I see here. If it's a positive leading coefficient, the left side points down and the right side points up. Whatever happens in the middle, we'll see. And the same thing here. For the left side, if we put a negative in front, the left side points up and the right side points down. And that's what we're going to look at very quickly here. We could graph these if you wanted to. You could graph each of these pretty quickly and get that. It wouldn't be very hard, but we're just going to talk about what's happening on the left side versus what's happening on the right side. I'm going to see if I can use my chart up there to talk about it. For this first one, we have our exponent is 2. That's an even degree. So I'm looking on this part of my chart for my even degree. Okay, so we have an even degree of 2. Is it a positive 2 or is it a positive x squared or negative? And since the number in front of the x squared is a positive, we're looking right here. And if you look at this box where it's an even degree and it's a positive leading coefficient, both ends are pointing up, something I could do without graphing is realize that both of these point up. Now, the other thing you could do is you could run to the graphing calculator really quickly here and see if that's true. If we type 10 plus x to the second, you're going to see, if I zoom out a little bit, you're going to see that's the case. The left side's pointing up and the right side's pointing up. So we have a way to check this. But we can move along a little bit faster here. We have the left side again and the right side again. I'm just going to put L for left and R for right. If you look, this one has an odd degree. So for this one, we have an odd degree of 3. Okay, the degree is odd. And so for this, we say, oh, if it's an odd degree, I'm over here. They're going to be different. One's up, one's down. Well, since the number before x to the third is a negative number, I see it right here. My left side's going to point up and my right side's going to point down, just like my chart says. And again, you could type this into your calculator to get that. So I'm going to run through all of these here. To get this video wrapped up, we have x to the fourth. That's back to even. The number in front of x to the fourth is a negative number. So I'm looking here, and it looks like with even degree, if it's a negative number as a coefficient, both going to point down. So I've got down and down. So down for both. Okay. And so if you're going to try these out, you can pause the video really quickly to see how you do. I'm going to write these down pretty quick. We've got x to the fifth. That's an odd degree. We have a positive number before that. And so I know very quickly that the left side points down, the right side points up. Keep going. We see it again. Degree is 6, but the number before that 6 is a positive number. So even degree, positive coefficient, both going to point up. So the left side is up and the right side's up. Last one, our degree, if you look carefully, is a 7. That's the biggest exponent. 7, that's an odd degree, so it's one of these two cases. Since the number before this, the coefficient is a negative 8, we're looking here, where the left side points up, the right side points down. And that's where we're going to leave it today. We're just analyzing these equations and these graphs. And you can type all these into the graphing calculator to help you out. All right, so on here, what you're going to do today is you're going to go on to the next page and practice these things, okay? You're going to state your coefficient. That's the number before the variable x. So in this case, the leading coefficient is that number 3. But the degree is, remember, that's always the exponent. So make sure you keep those under control. And keep track of whether your coefficient is positive or negative. You can graph these if you need to, okay? For some of these things, I'm going to help you out for all of your graphs today. Every single one, the domain is going to be negative infinity to positive infinity. That is not going to change for us until next semester. So for every single graph today, go ahead and put negative infinity to positive infinity on these. What you do want to pay attention to is what's happening with your range. And the range for all these graphs is low to high. What's the lowest it goes? What's the highest it goes? And for some of those, we have to think about if it's a number, sometimes it's going to be an infinity, okay? So check those out. We'll probably give you an answer key or check those with you, okay? Do the best that you can on that domain and range, but you really give attention to this leading coefficient, degree, and what's happening on the left and the right side. All right, good luck, and reach out if you have any questions.